This is Kelly Hill, technology reporter with RCR Wireless News. I'm here today with Xavier Lesage Moretti, who is a wireless engineer with Azimuth Systems. Welcome.
Hey, Kelly. Thank you for having me.
Great. Now we are going to be talking about Wi-Fi testing, and it sounds like Azimuth Systems has been doing some interesting things in this area lately. So I'm wondering if you can start off by telling us a little bit about what you folks have been doing in the area of Wi-Fi testing.
Sure, of course. So Azimuth has been providing solutions to test Wi-Fi communication systems for 10 years now, but also cellular by designing basically equipment that can emulate the air interface between a transmitter and a receiver, regardless of the technology. Traditionally, in order to test the performance of Wi-Fi communication systems, the most common tests that we call RVR tests is a test where you measure the throughput for different attenuation values, as if the device was slowly moving away from the access point. But the way people use Wi-Fi today is not the same as 10 years ago. And we've seen that varying the power of the downlink signal is not enough anymore. For instance, when the Wi-Fi signal bounces on the walls, it creates time dispersion, also called scattering. And if the user moves with his smartphone, it creates Doppler shift. Those two properties of the air interface need to be tested as well. Also, in the past, cellular and Wi-Fi have been tested more or less independently, but now smartphones have both, as you know, Wi-Fi and cellular capabilities, and we've been seeing more and more heterogeneous networks. So there's more and more emphasis from operators and device manufacturers to improve the end-user experience regardless of the wireless technology. And we've seen operators integrating Wi-Fi into their networks, for instance. So this is definitely a trend we're working on at Azimuth to try to keep offering the best testing solution because we see a big gap in the industry. And there are services trying to leverage this richness of wireless technologies, but for different purposes. One of those applications is positioning, which can use GPS, but also Wi-Fi positioning. And this needs to be tested before it can be released in a commercial device, obviously.
Okay. So let's talk a little bit about Wi-Fi positioning. What are some of the use cases for this? And can you talk a little bit about applications for that technology?
Of course. So positioning in general is needed if I want to use my smartphone to go from point A to point B, for instance, right? Or if I want to share my location with my friends, but also for emergency purposes like 911. If I call 911 for safety purposes, they need to have a very precise idea of where I am right now. So let's say that I am outdoor. If I am outdoor, I will be using the GPS, right, the global positioning system. Mm-hmm. If I'm within clear line of sight of 4 GPS satellites, by reading the signal they transmit, I can know where they are. I can know at what time they transmitted the signal and how long it took for the signal to reach me. And by doing so, I can determine how far I am from satellite 1, satellite 2, satellite 3, and 4, and therefore I can get my position. Mm-hmm. But GPS is generally not suitable to establish indoor locations, since microwaves will be attenuated and scattered by roofs, by walls, and other objects. So it gets tricky when I am in an office building or in a mall, for instance. And that's why it makes sense in some indoor scenarios to use the surrounding Wi-Fi signal instead of GPS or in combination with GPS to know where I am. And as you know, almost all carriers plan to invest in carrier-grade Wi-Fi by 2016. One of the reasons for that is that they see this as a way to provide better positioning in their network. So in theory, Wi-Fi positioning could also be used for public Wi-Fi, but it would just require to know the exact position of each router.
Yeah. So let's talk a little bit about how Wi-Fi positioning works. Now, you mentioned some of the basics just a minute ago, but can you talk a little bit more about that and about the testing process that you use to test this technology?
Okay, okay. So, there are many different possible implementations for Wi-Fi positioning, and I'm not going to get into the details, but the basic idea is that if I am in an office building and if I have an accurate map that tells me where the Wi-Fi access points are located, by reading the signal strength and the round trip time from each individual router, I can figure out where I am in 3 dimensions. And this is very similar to how GPS works with satellites, if you think about it. And our perspective at Azimuth is that we know that our customers need to test their products and that they don't want to walk back and forth 10 times in the building with their equipment because it is time consuming and therefore money consuming. So we've designed this solution called Field to Lab, which lets them replay this whole environment in the lab. In short, they just need to collect the data once by measuring the signal strength and other metrics, and then our software will play it back in the lab for them. So for this specific project, we got a little scanner that reads and saves the Wi-Fi signal. Mm-hmm. As I walk towards access point 1 and away from access point 2, for instance, the power of the signal from AP1 increases and the round trip time decreases, while the power from access point 2 decreases and the round trip time from access point 2 increases. So, of course, this process works for as many access points as you want. So once I have collected this data once, I just need to import it to the Azimuth software that will play it back in the lab as many times as you want in a 100% repeatable fashion. And this is where the engineers in the lab will be able to easily see if their positioning solution works as expected.
Okay. So let's talk a little bit about some of the challenges of testing Wi-Fi in the real world. You mentioned being able to record and then take it back to the lab. So when you're talking about doing this in the real world, what are some of the challenges involved?
Well, so there are challenges at many levels. First of all, from a logistics point of view, for the field test engineer responsible for collecting the data, it is very challenging, especially in public venues, to test the Wi-Fi network of the Super Bowl stadium, for instance. Right? You need to collect this data, or even just to do some field testing in a mall. He needs to, go from point A to point B with all his equipment, and the mall security team might not feel very comfortable about having him here going back and forth with all his unidentified gear, and sometimes he will be politely kicked out. And I am speaking of a personal experience here. So, but most of all, if the engineer goes from point A to point B twice on run 1 and run 2, it will not be the exact same signal environment in both runs, and therefore he might see an issue happening on run 1 but not on run 2. And as you know, when you're trying to test a product, repeatability is absolutely essential. So this is the challenge from a field test standpoint, but the other challenge, which applies to testing Wi-Fi but also wireless in general, is that we see a whole new paradigm where the increasing complexity of the RF environment impacts downlink but also uplink interference, right? So, the waves, the electromagnetic waves of Wi-Fi, 2G, 3G, LTE, small cells, macro cells, etc., all add up together. And on top of this, more and more objects are connected wirelessly because of all those words you heard before, right? Machine to machine, Internet of Things,
Absolutely.
Connected cars, etc., right? So even if in theory each device or technology is supposed to use its assigned time frequency resources, we see that it's not always the case in a real world, and that's definitely a challenge too.
Okay. Okay. You've been talking a little bit about the conversions of Wi-Fi and cellular. Can you tell us a little bit about the challenges that come along with cellular testing, like in LTE?
Of course, yeah, absolutely. That's a great question. So indeed, LTE is continuously evolving with all those new releases, right?
Absolutely.
And the new features of LTE challenge the way we've been testing product until now. Every new release. So we need to make sure those new features achieve the performance we expect from them. We've seen, for instance, more and more problems coming from the uplink channel, while traditionally our customers test mostly downlink in their lab. So, for instance, let's take voice over LTE. So, for voice over LTE, as you might know, before voice over LTE, LTE was used for data only.
Yes.
So, YouTube, Facebook, emails, etc. But when a user wanted to make a call, he would automatically switch back to the legacy 2G, 3G, so-called circuit switch network, and seamlessly, of course. But now, operators are moving voice from the 2G, 3G circuit switch network to the LTE packet switch network,
yes,
which does not come without constraints. For example, latency. Because for data, a small delay is acceptable. For if I want to get my emails, or if I want to update my Facebook page, right? But as soon as you move to voice, it is not acceptable anymore, and I need to receive and decode the signal in real time without this delay, without this latency. And for that very reason, voice over LTE comes with a feature called TTI bundling, which will essentially add redundancy on the uplink if the uplink channel is bad, to ensure fast, error-free delivery. And from an RF testing perspective, that means that it is essential to emulate the real uplink channel conditions in the lab, and that emulating only the downlink conditions from the field is not enough. And this is only one of many features we need to keep on the radar. So yeah, so to summarize, as everything goes wireless today, and as the end user becomes more and more demanding, products need to be tested in an environment that is at the same time controllable and repeatable, and a faithful representation of the real field. So at Azimuth, that's exactly along those lines that we've been designing our testing solution.
Okay, great. Well, thank you so much for your time today. I've been talking with Xavier Lesage Moretti, who is a wireless engineer with Azimuth Systems. Thanks so much.
Thank you very much, Kelly.